Alright, so we've got a histogram question here. If you want to pause it and have a go. Histograms are particularly poorly done, I feel, in the students that I've taught histograms to often get mixed up with them. Okay, so they're giving you a histogram this time. Frequency density isn't given, the scale isn't given, so that's obviously something we need to work on. So there are 20 members aged between 25 and 30. Now 25 and 30 is between here. Okay, so it's saying there are 20 members aged within this. Now the thing with histograms, it's all about area. So if you know the width of the bar is 5, the frequency is the area, so it's 5, and you sort of think, well, what do I times 5 by to get to my frequency? So what you're going to be doing, you're going to be doing the class width times frequency density equals the frequency. Now this time we know the frequency, we don't know the frequency density, so what we'd be doing is doing frequency density, frequency divided by the class width. Okay, so the frequency we know is 20. We're going to divide that by 5. So we know the height of this bar is going to be 4. Okay, so then it's to scale up. If you look down the scale now, that's 4 there. So it's normally quite a good scale. So you've got, every darker line here is 1. And then 3. And then from that, we need to work out all the other frequencies, because it's asking the probability the member is more than 30 years old. So we need to know how much these are. Okay, so let's just work that. So it's 20 across times, and that's going to be 2.5 is there, so 2.6. So 30 to 50, it's going to be 20, it's 20 across times 2.6. Okay, work that out shortly. And then on this one, 10, 20, 30 across, so on the range of 50 to 80, that goes to 30 width times, and then if you look at this, it's 0.3. Okay, and what that will give you is the frequency of those two. We will need to work out all the others because we need to know the total, because it's obviously as a probability of the rest, so we actually need to work out all of them. So 0 to 10 is 10 across, and then times 0.5, 0.6, 0.7, and then 10 to 25 is 15 across. See there, and then go exactly 2 up. Okay, so once we've got a scale, we can work out how the frequencies of all of these. Okay, so it's a non-calc paper, so you should be able to do most of the questions here. Should be able to do not really much problems. It's just decimal timesing. So 10 times 0.7 is that. Tips and tricks, so you can kind of work it out. So if you're timesing decimals, if you have trouble with doing that, get rid of the decimal and then put it back in again. So 30 times 0.3, just think of it as 30 times 3, which is 90. But it's not 3, it's 0.3, so you're moving it down. So instead of 90, it would be 9. Same with this one. I'd probably do 2 times 2.6, which is 5.2, but it's not 2, it's 20. So what I can say. Okay, so instead of 5.2, it's 52. Okay, and then we can add all those together, obviously not forgetting the 20 from when you're given. So that's going to be That's 52. You can see how it's quite a lot bigger, isn't it? So it does look like it's going to be quite a lot bigger. That's 9. That one's 20. This one's 7. I've not done this in a brilliant order, but hopefully you can see what I've done there. And if you add them together, 20, 30, 52, 7 and 9. 5, 10, 11. So it's 118 in total. It's not a lovely number, but it doesn't really matter because what you're doing, you're finding the probability that the member is more than 30. So it's 52 plus 9. So that's going to be 61 in total out of 118. So you just leave it exactly like that. So I hope that's given you a little bit of an idea of a histogram style question. Again, this is quite a late question on the paper, and many people would always get confused bar graphs versus histograms. So it's just remembering it's all about the scaling on the frequency density and finding the area. The area is the actual frequency itself. Okay.